Hello, statistics student. This video is for chapter 4.1, discrete random variable. So we introduce a parameter of a discrete random variable from a PDF, which is a table that lists all the x and p of x. And we are going to use those to calculate some values and understand how we can use those PDF. Okay, first, x is number of year a new hire will stay with the company. So it is called, so technically number of year could be less than, it could be a continuous random variable, but I think after rounding, you can round it to a year. Okay, so it's not a very good example, but maybe round it to the nearest number of year that a new hire will stay with a company. So we have 0 to 6. X can be 0 year. That means the new hire does not finish one whole year, 1 year like this up to 6 year. And this is the probability. So probability usually, in this case, probably is a chance that calculate from relative frequency. You look at a whole bunch of new hire and then you calculate what is the chance of they stay 1 year up to 6 years, etc. So first of all, we have to check if it is a valid probability distribution. So how do I check? We have to add them all to add the p of x together, right? 0.12 plus 0.18 plus 0.3 plus 0.15 plus 0.1 plus 0.1 plus 0.05, and it's exactly equal to 1, so it is a valid one. If it's a valid one, we can calculate mean, variance, standard deviation, and also use the mean to determine what is the expected number of year a new hire will stay, kind of like the typical number of year that a new hire will stay, because X is random. It can change every time you have a new hire. So I have this enter into the LibreText expected value and SD calculator table because for mean, we probably can 0, 1, 2, yeah, here 0, 1, 2, 3, 4, 5, 6. So what you do is you do LibreText this and then online expected value and standard deviation calculator. The link is also on Canvas under calculator list. So you enter the p of x, it's just copy them over, right? This is x and this is p of x, copy them over. And then you just hit calculate and it would give you the expected value 2.43 and 1.6508. So we can go back to here. We say, okay, 2.43, we round to 2.4. Sigma is 1.65, but variance, we would do the whole thing 1.650x squared before we round. So don't round too much. Usually I calculate the variance first, and then I'll, using the whole sigma, and then I calculate sigma. The expected number of year that new high will stay is 2.4 years. So by chance, you can have any of them, but on average, you have a lot of new hire. The number of times the new hire will stay would be 2.4 year. Now so this is the average. We can use the table to find more specific probability. Find the probability that new hire will stay for 4 years or more. So on average, it's 2.4, but what is 4 year or more? So we could just use the table. Exactly 4 year is 0.1, right? 4 year or more means 4 or 5 or 6. So this is the probability of the 4 year. This is the probability of 5 years. This is the probability of 6 year. Or means they can have any of them, right? So it's 0.1, 0.1, 0.05. So it's 0.25. So remember, or is you use the addition rule. So that's what you do. And they are mutually exclusive. So you can just add them. You just use the addition rule for mutually exclusive probability. C. Find the probability that new high will stay for between 3 or 5 years, inclusive. That means 3 to 5 years. Right, 3 to 5. So we just read off 3, 4, 5, 0.15, 0.1.1. So you can see 0.15, 0.1.1, add them, that is 0.35. Find the probability that new high will stay for 2 years or fewer. What does 2 year fewer? That means less than 2 years or equal, right? So it's 2 year or below, or at most 2 years. So it'll be 0.12, 0.18, and 0.2. We want to find the chance that I hire someone, and then you figure, is it a chance that they will just have to stay just at maximum 2 years? So you do the first, the first 3, 2 year or fewer, up to the, the least possible one, 0.12, 0.18, and 0.3. Is it 0.3? Yes, and 0.30. So that would be 0.6. So 60% chance that someone will actually stay just less than 2 years. And then E is find the range of non-significant year of stay. So what is the year of stay that is not surprising? So not surprising would be 2.4 minus 2 standard deviation and plus 2 standard deviation. So 2.4 minus 2.165. Again, I'm going to draw the number line so you can visualize it. So on average is 2.4, but 2 standard deviation is 2 times 1.65. And then back to standard deviation is 2 times minus 2 times 1.65. It turns out it is 0.09 to 5.7. So you can say that, they have different probability of having them stay within certain number of years, but staying from 0 to 5 years is not surprising. But staying over 5 years, that means you see 6, 5.7 is the last number. 6 is over 5.7, so 6 years is very rare. So that's how you can interpret non-significant. Non-significant means I'm not surprised that people stay from 0 to, of course, there's no negative, but in terms of the bound, it can go up to negative. That means 0 is not surprising, but 6 is surprising, unlikely. Question number 2 is X. You have a PDF here given, X and P of X. X is the number of textbook a student buy per semester. So how many textbooks do you buy? What's the probability? What is the expected number of textbooks? So what is on average a student buy? So you find mean, variance, and standard deviations. We don't use this calculator. We use the LibreText, so it's a typo. Is a LibreText, the one that we used before. LibreText as expected value and SD calculator. So I actually enter it already. So is it this one? Yes. By 1 textbook is 2%. By 2 textbook is 3%. Right? 3%, 0.45. So you just enter them and then you press calculate. It's 3.5 expected value and standard deviation is 0.781. 3.5, the standard deviation is 0.781 squared, so that's 0.61, and the actual standard deviation is 0.78. Okay, so expected number of textbooks that a student will buy. If you to randomly ask a new students, and then what do you think the number of textbook that student will buy is 3.5 books. Okay, so that's A. B is find the probability that student buy at least 5. What does at least 5 means? At least 5 means 5 or more, right? 5 or more means 5 is the least one. Okay, so it's not less than 5. At least means 5 or more. So you will say 5 and more is 6. So you do 0.03 plus 0.02 is 0.05. So that's quite unlikely. Find the probability that X is at most 2. So there is two books, right? At most 2 books. So what is the probability of at most 2 books? 1 book is less than 2. 2 book is 0.03. So that would be 2 or fewer. At most 2 means 2 or fewer. 0.02 plus 0.03 is 0.05 also. Again, we also ask for the range of non-significant range. So because standard deviation is 0.78, so we just do, and mean is 3.5. We do 3.5 minus 2 times the standard deviation to 2.5 plus 2 times the standard deviation. So that would be 1.94 to 5.06. So if you analyze this, what is surprising? 1.94 is not surprising. 5.06 is not surprising, but in between them is not surprising because 3.5 is the average. So this is non-significant. They can occur by chance. By chance, they can show up. You are not very surprised, but you can see that 6 book is greater than 5.06 is surprise. 5 book is not surprising, and 1 book is surprisingly low, right? because 1.94, no, 2 is not. Okay, 2 is not surprising. 2 is within it. So when you ask a student, how many books do you have? If they say 1 book, you're, oh, that's very surprised. 6 books, that's also very surprised. They are significant, whereas the middle in between are not significant. So we also have some application in 4.2. So we'll talk about application of probability distribution in the next video for 4.2.